Hello, here's Ms. Walsh, and today we're going to do day 5, equations of tangents in differential calculus. Okay, so we already know how to find the slope of the tangent at any point. Remember, you can either take the derivative and then substitute a specific point, or you can do this directly on the calculator. So what we're going to do today is these are our tangents, and we're just going to extend one step further, and instead of just finding the slope, we're going to find the whole equation. Okay, so for the first one, remember what this means. So find the derivative at 4. What this means is find the slope of the tangent at x being 4. Okay, so let's enter this into the function. And then, so 2x squared minus 3x. Okay, plot it. Okay, so we're at 4, so we are after somewhere up here. Remember, we're going to go to, just put in 4. And then function, and then you're going to go to slope. Remember, when you hear derivative, then you hear slope. Okay, so what we see is that at 4, the slope of the tangent is 13. This kind of makes sense because what you see, 1, 2, 3, 4, is that it's a positive slope. So that already is a good sign, and you know that it's fairly, oh, I can't draw it on this, I'm stupid. Okay, that it's a positive, fairly steep slope. Okay, remember what this is. All this is asking you for is this is asking you to find the y when x is 4. Again, now you can just go to, or if you want to, you can also go to num, and then you see that when it's 4, it's 20. Okay, so now is the slightly new part, but it's actually not new. All it is this is just some equation of a line, yeah? So you do the same thing that you have done for years, which is either your mx plus b, or if you prefer the point slope form, whichever form suits you better. Okay, so here we go. It's all gonna happen. Good. And there is our slope somewhere there. Okay, so remember what this actually is. What we have then is our slope is 13 and our point is 4 and 20, okay? So now I'm gonna use the point slope form. If you don't like this, too bad. No, I'm just joking. Just use your mx plus b, and you should arrive at exactly the same point, okay? So this is y minus 20, and this is 13x minus, what is this, 52, isn't it? And then we're going to add 20 to both sides. And so our equation is going to be y is equal to 13x minus 32, okay? So what we've actually found, 1, 2, 3, 4, is that here, it's the equation of the tangent. Okay, that's a terrible line, but anyway. All right, second one. Now a little bit for context. The side of a hill can be modeled with a function of like this. Sketch the graph. Okay, let's do it. By the way, notice that the values here are pretty small. Pretty small. Which means that you're probably gonna not get a nice graph when you just hit enter. So you might have to adjust the window a little bit. See, this is not so nice. I don't know. Maybe why don't we go to like 12, and let's make this from 0, and let's make this, I don't know, maybe 50, something like this. Okay, so it increases really slowly. So what we could do is we could even go to shift plot, and let's actually go further. And then remember, good old view auto scale will also give us, okay, whatever, there's the hill. Okay, so there's a monastery at top of the hill. So this looks something like this. Starts at 0, 0, and then eventually it's a hill. By the way, if you wanted to know this point, maybe they'll ask us for it, then you can just find the route, so you know what you're drawing. Okay, monastery at the top of the hill, which could be an interesting tourist attraction. It's decided to build a funicular railway to reach an almost top of the hill. So it can be modeled at the curve at x is equal to 50. Find the derivative. Okay, so we're going to find the derivative first. So here, they're asking us to do this the long way, right? So they're actually ask us to derive. So this is going to drop. So this is going to be minus 0.04x. plus 3.4. Remember what this is. Remember what the derivative is this is all the slopes. Find the gradient of the tangent when x is equal to 50. So now find the gradient. As soon as you hear gradient of a tangent, slope of a tangent, you hear derivative. So that what they're asking us to do is they're just asking us to substitute this in. So 50 plus 0.4. Let's do this. So we're going to go negative 0.04 times 50 plus 3.4. Okay, 1.4. Just to show you that this is the same thing. If you're not asked to actually find the derivative, if the question just asks you for slope of a tangent at a specific point, don't do it manually, okay? Just go to what you want, which in this case is 50. Then remember, you want your function, your slope, and there's the same answer, okay? Hence, find the equation of a tangent. Okay, so 50, where is 50 anyway? Let's go to 50. 50 somewhere up there, so my sketch is not all that good. But basically, this is where 50 is. Whoops. The reason that I know that it's somewhere before the maximum is because the slope is positive. And whenever you have the positive slope, you know it's going to be something like this. Okay, hence find the equation of the tangent and sketch this on the graph. Okay, well, remember what we need. And actually, I'm going to do this one in mx plus b form. So the first thing that you need is you actually are going to need a y value first. You already have the slope, right? That's your derivative. Derivative equals slope. Derivative equals slope. Slope equals derivative. Slope of a function, slope of a tangent, same thing. Okay, and now you always need a point. So this is just 8th grade skill, right? So 50, you can either scroll down or you can just go to 50, see what the y is. Okay, it's 120. And so now it's just mx plus b, okay? So 1.4, this is 50, this is b, and now we can finish. It's 50 times 1.4, who knows, 70. Take off from both sides, minus 70, and that's equal to 50. And so your equation is equal to 1.4x plus 50. Okay? So again, the scope of the lesson is that you get the derivative, you get the slope of the function by finding the derivative, short way or long way. Then you also use the function to get an actual point, and then you get your function. Good luck.